Hi, I am William Hill from Myanmar. I am now making a presentation for my database engineering subject, and the chosen title for my assignment is Community Center Voting System. And this is the ERT of the database for my assignment, and there are 7 tables in the database: addresses, users, center, staff, rooms, booking, and booking frequency. I created these tables using SQL query, and this is the creation of address table, and this is the result in the database, and this is the data insertion into the address table with meaningful data from the real life, and this is the result of data insertion. This is the creation of booking frequency table and the result. The query for the creation of result table and its result. And this is the query for creation of center table and its result. The start table is also created using the query, and this is its result. Rooms table also created, and finally the booking table. And now I will present you the 11 queries that demonstrate the usefulness of the database for my community center booking system. The first one is the query the use order by. In this query, I selected the room number, center name, search by day from the tables rooms and center. The two tables rooms and center are joined in the where clause, and I use the order by for search by day from the rooms table in the descending order. So this query is useful as the staff who use this database system can view the sorting of the rooms and center in the descending order. I will run this query. So the top row will show you the most expensive search by day of room number and center name, and in the descending order, the last row will be the most cheap search by day of the row. The second one is the query that used inner join, and in this query, I selected the user ID, user first name, user last name, and the user address building number, user address string number, and user address city name. It need to inner join both address table and user table with a column of address ID. I will run this query. And this is the result of this query. This is the customer detail of from the database with inner joining the both user table and address table. Customer or staff can view their data in naturally like in real world without the IDs. And this is the third query, and this query uses the subquery in the where clause. In this query, I selected the center name and the count of the booking ID. I need to join the booking rooms and center tables in the where clause, and In the subquery, I selected the row number ending in 2. So this query will give you the row numbers ending in 002 or 2 and the row number center name and count of its booking. This query will be useful because this query can do complex processes in a single query. The fourth one is the query that uses a partial matching in the where clause. In this query, I use partial matching like row number starting with RG keyword, and I selected row number and its center name and its user first name, last name, and address, email, phone number. So this query select the user's detail, which book the room number start with RG. So the customer Mao and Mumu book these rooms starting with RG, and their details are shown later. So this query is useful because we can find the detailed information using only partial available information. The fifth one is the query which use aggregate function. In this query, I use the aggregate function average. I selected the center name and is average charge party of its all of its room. So I join the rooms table and center table in where clause and I group it by center ID. So each center and the average rate of its rooms were shown here. This query let the user to check the average rate of each center, and the staff can pick out the most expensive center to visit or the center with each name with the average rates. The sixth one is the query that use the group by having clause. This query selected the user first name, last name, user email and phone number, and their total number of bookings using the count aggregate function. I join the booking table and user table info clause group by user ID and having the condition of total bookings greater than or equal to 3. So only the customer which booked more than 3 or more times were shown here, and order by total booking. So from minimum to maximum sorting. This query is useful because the total number of booking or for each user can be viewed, and the combination of more than 3 is also make it useful by selecting the most loyal member or user for this community center booking system. The seventh one is the query that uses subquery as a relation. In this query, I selected many columns. I will now explain the inner subquery first. In the inner subquery, I join the booking, user, room, staff, sender, all these 5 tables in where clause and order by booking ID. And I selected the booking ID, booking frequency code, user first name as username, and roll number, sender name, and staff first name as staff name. And this subquery will be used as a relation and alternative name as BD and booking frequency alternative name as PF. This subquery as a relation is joined with booking frequency table in the where clause, and the condition is the daily usage for booking. And the selected column are booking ID, username, roll number, sender name, and staff name. So the result will be the booking detail of user name, sender name, staff name, roll number, and the condition is they should be booked for daily usage. This query can be used to generate reports by the staff, like daily. You can change the daily to weekly, or monthly for other reports. This query is a query that you subjoin. So this is the complicated query because it joins 2 tables at same table, and I join it using search party. This column will show 2 rows which are equal search party, and row numbers will be row ones in ascending order, sorting in ascending order. This query can be used to check the row numbers which have the same price, so the staff can compare them to make reports. And the next query is creating a view. So I write this query, create a workplace, so I have already the same view in the database, so I can run, and the view is the replace. This view query is the booking detail, so all the 5 booking rooms, user, staff, booking frequency. All these 5 tables are joined in where clause and generate a temporary table for the view booking detail. The view can be selected here, and this is the view I just created. Creating a view is useful because the view will act as a temporary table other than the original table. So data security is enforced more, and the user can only view the data and will not be able to insert, update, or delete the original data. The next query is the using a view as a relation. So I use the previous created relation in this query, view booking detail, and alternative name, PD, and rooms center. All these three tables are joined where clause and the condition is that booking date from is greater than 2017 December 1st. So only the data 2017 December will shown here. 2017 November data will be neglected. So I will run this query. So booking date from only later in December will show here. Here will be the booking ID, the booking roll number, and center name, which are later than December 2017. November 2017. The booking detail will not be retrieved every time. It can be retrieved from the view, temporary table view, booking detail. It is more efficient and more secure. The last query is the trigger for the database. For the trigger, I will drop the trigger in case of it is created in my testing. So before creating a trigger, I can insert the date of birth like 2005. So the step will be at 12 years old and it will not make sense. So I will insert it and it is inserted here. It is not meaningful, so I will delete it again. And here there is no row. So I create this trigger, check DOB, date of birth, and this trigger is created. This trigger is executed before insert on start table, and for every row it will check the condition of date of birth will be greater than 1999. If the date of birth will be greater than 1999, the error message will show age enter 18. It should be entered the less than 1999. So every step should be at least 18 years old. So I will insert this query again, and here now this cannot be inserted because the trigger will show the message age enter 18 because this 2005 is greater than 1999 and this step is only 12 years old or human errors. This will conclude my presentation. Thank you for your attention and have a nice day.